while we're waiting for people to filter in, is anybody feeling particularly motivated to take notes? Because otherwise we're going, oh, thank you. Thank you, Tommy. That's actually very helpful. Marcus, I can't see from here. Marco. Thank you, Marco. It's very difficult to see the actual audience up here because they're pointing really bright lights at us. So I just saw a mask and assumed. Okay. Yeah, we're going to wait probably a couple more minutes for filtering in.
Like retina burn.
Yeah, I literally can't see. Like. Okay, this is the quick working group session for Ietf 123. If that's not where you intended to be, you can exit now. If not, we're happy to have you. So we're relatively late in the week, but still it's important to note the procedures under which we all agree to conduct ourselves at the Ietf. So please familiarize yourself with the note well, and also some of these other guidelines for contact at the meeting. Well, Lucas is messing around with the time. Okay. We're going to breeze through some of these meeting tips since it's Thursday. But basically, the chairs will be managing the queue, so you don't have to fuss with removing yourself or remove you. The chat is the normal situation with Meetecho and Zulip. And we already have a very generous offer of note-taking. Thank you, Marco. And yeah, so our agenda, we have actually a lot of working group items now, whereas previously we didn't have so many. So we're gonna have a walk through multipath, extended key updates, address discovery, ACK frequency, lots of ACKing, ACK received timestamps, and then quick stream multiplexing, also known as QMUX or other various things. And then we have some as time permits items that we may be able to get to as well. At this point, does anyone want to bash this agenda? I'm going to assume not, but I don't. But if you really would like to, okay. And with that, I think Lucas, you're gonna talk through some other things.
I'm muted. Hello. Yes, so as Matt said, we got a lot of active drafts. We don't have people to present for all of them, so I'm just going to give a brief summary of some of the ones not on the agenda today. QLog, and since the last Ietf, we've published one on the 7th of July. We closed 4 issues, plus some doing editorial changes in Tweak. We have 13 issues remaining. The editors are setting up time in August, September to try and drill through those, but any help or input, welcome. Please just go and take a look. Some of them are around handshakes and TLS. We struggle sometimes to try and anticipate how both implementers of QLog, but the transport and Quic libraries say, are trying to use these things and what value they provide, which is where some of the time and cycles ends up being drained on the editors. So any opinions are quite useful for that. We're not asking you to do the work and making proposals, but just sharing your ideas can be useful. We've also got the reliable resets work, which is effectively, from our perspective, still waiting on implementers there are some discussion on the repo. If you're interested, take a look. We can resolve those things. But the main blocker is the implementations. In the Web Transport Working Group meeting yesterday, we discussed the implementation of Web Transport, of which reliable resets is a dependency. The plan there is to initiate a working group last call soon, and that might motivate implementers to do some work and do the reliable reset stuff. So I think when we come to the next Ietf meeting, we'll have a clearer view of if reliable resets is ready to be sent onwards outside of this working group and towards standardization. And finally, the load balancers work. Martin Duke might want to correct me here. My understanding is we're still gathering deployment experience there. I don't think there's anything more to say. I see Martin stood near the microphone, not in the queue. No, he doesn't want to say anything. Okay, cool. That was Martin Seaman, not Duke, just for the notes. So yeah, that's the next slide. Do I have control? No. And I wanted to take some time to do a recap of the June interim meeting that we held, in case people just come to the Ietf meetings. Following Ietf 122, where we discussed QMUX, Quic on streams, whatever you want to call it, this notion of taking Quic's streaming model and making it available to other things. There was sufficient interest in that room to hold an interim to explore this topic further, to really figure out what that work might look like, where it might be done, confirm that there is interest in actually doing it. And we had a good session. I'd say the outcome was that we did want to do the work. There's several people interested, and that we wanted to do it in the Quic working group, but that it didn't really fit into the existing working group charter. And so we spent some time on that call, patching the charter effectively, or coming up with a proposal to. If you could go on to the next slide, Matt. I'm not going to we're not relitigating this text, but this is just to provide an overview if you've not been following along. This was went through a few rounds of iteration and was sent to the list for confirmation that this is what the working group consensus is on proposed addition of a fourth work item to the Quic charter. This has now been handed to our AD, who's got the IESG ballot work started. I believe tentatively this is on the agenda for the next tele-chat on the August the 7th, so not too long from now, and we'll see what the feedback is on that. Next, assuming that all goes well, we'll be seeking an adoption of a specification to allow us to deliver on this work that we're saying we want to do, because it will come up later on in this session to discuss an exploration of potential protocols that might help us and the way that we might make the wire format for this thing work. We haven't changed the charter yet, so we're not looking at adopting any draft in this session, and we're not going to talk about it formally, say, but we want to spend some time to get everyone baselined on what the different options could be, and to give some thought that we could work in the meantime before the next Ietf to allow us to come up with proposals or a shape of something that we can, in the next meeting, assuming the charter has changed, consider for adoption. I see Gori is up at the microphone. Would you like to add something, Gori?
Gori as AD, that all sounds totally correct. Thank you.
Thank you. That's nervous then. Christian?
Yes, on the QMUX part for adoption and charter modification, I would love if the charter said secure as well as reliable. I mean, I am really worried that QMUX is a way to the NSA smiley, and I'd like to avoid that.
Sorry, Christian, the audio isn't that great in the room. You said you were worried QMUX is a way to something.
Okay, let me repeat. Do you hear me?
Yeah.
Okay, yes. I am worried that running QMUX over insecure streams is a way to repeat the disaster of the NSS smiley. That is, have a way to break encryption of Quic and expose ourselves to attacks. And I would love if the charter modification, as well as saying reliable and bidirectional, said secure.
I have the charter text up on the screen now. I can read it.
Yeah,
and what we-
I read it. You offer a reliable and bidirectional byte stream.
Yes.
I would like it to be a reliable bidirectional secure byte stream.
Christian, I think the next sentence says when the substrate is insecure, TLS will be the default security parameter. Security provider. Does that not cover it? As in, we will only work with a link that's already a path that's already secure, or we will use TLS.
If that's how everybody reads it, then I'm fine.
This detail we can check when we do the final version of the text.
Yeah.
Yeah.
Because I mean, it's much easier that to be part of a consensus that doesn't involve lowering the security or Quic.
Okay, I think, thank you for sharing your points. I don't want to take up too much time of this. This is something we can follow up and resolve offline. So let's do that. But thank you. Next slide. This is the last slide. Okay, so that's the end of the chair's section. Okay, we see a lot of people in the room physically located, but signed into the data tracker is maybe not as much as it could have been. So please remember, sign into Meet Echo. That helps us and do the blue sheets and get an idea of capacity planning and lets you participate. So please do that now. But next up, we have multipath.
Oh, it's really bright here. Hello, my name is Mia Kulewind. I'm one of the authors of the multipath draft, and we can go to the next slide, I guess. I can take the clicker. Not too many slides. Yeah. So since the last meeting, we actually submitted 2 new versions, but version 13 was a big editorial cleanup before we started working group last call, and then that's already wrong. Version 14 was the cleanup, and version 15 is the current version and addressed some of the working group last call comments. We got like 2 very detailed reviews from Tommy and Martin, and then also a bunch of smaller feedback and editorial stuff. So that was really good. Thank you for that. We managed to address most of the issues that were raised. We have still 4, 5 open issues that we discussed today, and then hopefully another version comes up and we are done. Next slide. So which were the issues that were raised and addressed with the last version? We renamed the status frames and the error codes. It's on the next slide, so you can double check it if you really like the names now. We fixed some examples, and there were various clarifications, and those clarifications also impacted normative language. But in a lot of cases, these were things that we already meant to say. We just didn't use normative language, or we didn't say it explicitly. So there's no recommendation about rather not sending keep alives, which wasn't as explicit before. There is about connection closure, there's a new should saying that the PTO you should use is the largest PTO from all passes, which was also not as explicit before. There is a new must saying that you have to send a pass challenge on a pass response on the same pass as a pass challenge using the same pass ID, which was also not a normative, using not a normative must, but it was there before. There is a must on supporting migration, which we didn't have before because we were just assuming you always still have to support RFC 9000, but now people felt it's better to actually say this explicitly with a must. And there is something on the maximum packet size of assumptions about passes, like even if you have a pass in the same 4 tuple, you can have different packet sizes effectively, and we just wanted to point that out. there's improvements in the text of the security considerations on DOS attacks, which is probably more than an editorial change, but hopefully also clarification and makes things more clear. And then a bunch of editorial improvements where we get like a lot of small comments and everything. So really thank you for that. Yes. Doesn't look anybody has questions on that. So this is the name changes for you to review. We added the word status there for the status frames. And then for the error codes, we also added the word pass everywhere to make sure this is kind of focused on this extension. Yes. Open issues. Error codes. There was another proposal to add or rename error codes. In the past, we discussed this a few times. There were like no strong opinion. We added a couple of them, but we could have more or less or whatever. So the proposal was about like 3 things came up. One is communication failure. Another one would be poor performance. And the third one that was proposed was like timeout. In the discussion in the issue was kind of saying actually communication failure and pass or poor performance is kind of both covered with the same error code so far, which is this pass unstable. So we didn't really feel the need to separate those 2 things, but if people want them separate, we can do it. And then for timeout, it was more kind of, this is not really an error condition, that would be kind of just a normal closer decision, and that's probably not something you should have a separate error code for, so you maybe just use application abandon or whatever. But again, if people think it's useful, we can add them. And then there was also a little bit of discussion about renaming this error code, which we can bike chat on if you guys want.
Hi, Lucas Pardew. As an individual and error code enthusiast, I haven't been tracking this issue as close as I should, sorry, but I'm just looking at this slide and I see a mention of application abandon halfway down. What is that? Is that a new thing, or is it referencing some existing concept? It doesn't seem familiar to me. So is it a typo or?
Actually, yeah, no, so sorry. I don't think, yeah, it doesn't exist, right? That it was, so I think it's actually, no, we have it. This is kind of the non-error closure case.
Okay, let me take a task to go and follow up. Because, yeah.
But, you know,
Yeah, can I?
Go ahead.
Yeah. Yeah, I mean, application abandon is a normal case. It's why did you abandon this pass? And the answer is because the application said so. That's what that means.
Okay, so
it's the error code 0 effectively.
A newly defined multipath quick error code in the quick error code space.
Can you go back one slide? Yes, it's now called application abandoned path, actually.
Okay, so again, naming is time-consuming and tedious, but if it's got path in, that makes it clearer to me from a general quick implementer that this is abandoning the path and not the application of some other things. So yeah, that looks better. Thank you very much.
Yeah, also to comment on timeout, we don't have a requirement to have a timeout. So having a timeout is really an implementation side decision, so, and not necessarily an error case. Yeah, so I welcome people to comment on the issue if they have thoughts, but if I don't receive any further feedback, I will just do nothing and close the issue at some point. Okay, this is the one where I actually would like to, no, actually, this is the one. This shouldn't be too hard either, hopefully. So we are talking about uncoordinated abandon. So we had this case, we had an issue for it where like you open 2 passes on the same for tuple, which is allowed, but in a lot of cases might not be actually what you intended to, because like maybe you didn't coordinate on both sides and both open the pass and you only need 1 and then you have 2 and that actually doesn't make your situation better. And so in this case, we kind of recommend that like you implement a rule where where's always the client would be the one closing the pass if you want to close the pass. But it's not like anything written in stone, and we discussed that and we didn't feel like we could give like any binding guidance about this or whatever. So that came up again because it's like very vague guidance here. So we could do more, or we could remove the text, or we could do nothing. Christian, any thoughts?
If anything is controversial and not completely necessary, my feeling is that we should just remove it. But that's because I think the draft is already way too long. So, yeah.
Tenardi, I'm not sure why you would need a standard behavior here, and I would just take this out.
Alessandro Ghedini, Cloudflare. As an implementer, I don't understand what could adopt a simple coordination rule even means, right? So I don't think this is particularly useful.
Perfect. Great. We're taking it out.
Yeah, it's a leftover of discussion we had before we have the current design. And basically, we realized that it's entirely possible to have two different paths with the same IP addresses, and that the application might want to remove one of them. And that if the application did want to remove one of them, then the application could get it wrong, and the server removes one, and the client removes another, and we end up with nothing. That was what we were worried about. But that's kind of convoluted, and basically it's amount to saying that application don't shoot yourself in the foot. They already have 100 different ways of doing that, so I don't think that we need to case out this specific one.
Yeah, I think there's also some text still describing the problem. It's just we don't give any guidance. So, yeah. Good. Next. Okay, this is the one I really need some feedback on. This is also something we discussed and made a decision, but there's a lot of discussion on the issue now. So we all decided we need to bring it back here. And this is about the token for the pass. And like what we say in the document is what you can read here. It's basically saying that if the server issues a token, the token should be valid for all addresses that has been used so far. So then when the client wants to use the token later on, it doesn't have to remember necessary address. It can just use the latest token and it should work. But of course, this puts the burden on the server side that has to remember all these addresses. And so that was questions if that assumption is something we can accept, we should spell out, we should change. The proposal for change was here to always bind the token to just one path, and that's the path it was sent on. That would be the other option. But probably the minimal thing we can do is try to explain these assumptions more.
Right, Kazuhoko. So I think my high order question is there new information since we published RFC 9000 that makes us reconsider what we did? And for context, what we did in RFC 9000 was explicitly allow the servers to send tokens containing multiple IP addresses so that when the client happens to resume in a different address, for example, if it disconnects on the cellular and then it reconnects on the Wi-Fi, it can use tokens for use the resuming information for both addresses to recover fast. And I don't think that situation has changed, so there's no new information to reconsider what we did in RFC 9000.
Yeah, I think actually Martin, who raised this issue, might not be here. He said he had a conflict, so. Martin Thompson. But I also wanted to say, if you send a token and you're not remembering all the addresses, make wrong assumptions or whatever, then the assumption doesn't work, and then you have to do the whole process instead of fast resumption. But that is not a big issue.
Okay, so if speaking on behalf of the author group, Miria, do you have answers that you need to make progress on this?
So I think at the end of the discussion, we agreed to raise it here and make sure that we get input from the group. But if we don't get any new input, I think the working group consensus that we had established when the issue was raised a while ago stands, which is the current solution.
If it would help, we could do a formal consensus call on this issue, given it's one of the final ones kind of for the draft.
Here or on the list?
On the list, take it away. or we do it as part of another small working group last call for some of the edits that have happened on this draft.
So, I mean, at this point, I guess the only one who raised this concern is Martin Thompson, so we can follow up with him and
Okay.
say,
Yeah.
and then, yeah.
Okay. It seems like we have a reasonable number of ways
Yeah.
to resolve this. Thank you.
Sorry, I think the queue is not working for me. Can I speak anyway? Tilman Seschke from ETH Zurich. So my understanding was that there is an issue with the tokens getting too big and there also being too many tokens. So from the standpoint of Cyan, which is not an agreed protocol here, it would be good if we have a way to limit the tokens, because we have here a lot of paths and a lot of connections. And my understanding is there could be a lot of tokens, and that could be problematic.
I mean, it's on the server to decide to issue a new token, right? And then, but if you issue a new token, it should be valid for all the passes that has been active on this connection.
Yes. Yeah.
That's what we're saying.
We're running short on time for this section, so please.
Okay, so we can figure out if we can add some more clarifications about the assumptions we make, but we don't change the design. Next one. There's two more issues which we labeled editorial, but they're also different.
Sorry, for the note taker, can the previous speaker repeat their name for me, please?
Speaker, can you come to the mic to repeat your name for the notes since you weren't in the queue? Or can someone do it on my behalf? We can't hear you down here.
Put it in the chat, yeah, that works.
Please put it in the chat, yes.
These two issues are labeled editorial, but there are different opinions about which sentences are more clear. It's a matter of taste, I think. So I'm not intending to, at this moment, to take any action on these issues, but if people have strong opinions of that or want to engage in discussion, please do so now, basically. Yep, that's where we are. We finished working group last call. We had a new revision. We will definitely submitting another revision after this meeting to resolve the remaining problems, or issues, but I think we're mostly done.
Cool, thank you. As I kind of alluded to, I think maybe a short final working group last call once we hit issue 0, just to give everyone that final opportunity before we look at doing the shepherd's write-up and proceeding the progress.
Yeah.
But yeah.
Definitely.
Cool, thank you very much.
Thanks for the input, thanks.
Up next, we have the extended key update. Yaroslav is coming to the stage.
Hello, everybody. This is extended key update in Quic update. We don't have that many new exciting things. One update, we have another co-author joining us, Tiru Reddy. He submitted quite a number of updates to the text. Next slide, please. So to quickly recap what it's all about, with standard key update does not provide what some refer to as post-compromise security. So if unfortunate event of compromise happens, so for example, memory dump occurred, somebody stole memory of your process or your container or your virtual machine, then established sessions, Quic sessions, are compromised forever and ever, and standard key update is not going to help because it gets new keys from the previous ones. Next slide, please. And with extended key update, you limit exposure. Once you perform extended key update, it performs a fresh ephemeral key exchange, either Diffie-Hellman or PQ, depending on what you have negotiated. So your compromise window is reduced, and that is particularly important for long-lasting sessions. Now, there are discussions in 3GPP that Quic might be used for certain long-lasting sessions in 6G plethora of standards, so it is also quite important for them. Next slide, please. Right. So the most substantial update in 0.1 compared to 0.0.0, we've done sync with ongoing work in TLS extended key update. That is, instead of using just one label to rotate the key, we are using mechanism that is similar to getting keys during initial key exchange. So separate for client, server, traffic, exporter, master secret. And for resumption secret as well. There are discussions that are ongoing in TLS working group whether resumption secret should be rotated as well. As those discussions settle on something, we will update Quic draft accordingly. So in the past, again, in the previous revision, we had a single HKDF expand, and now we're mimicking initial key schedule with extracting every secret separately for better security properties. So we are working on few initial implementations, and if you have an implementation that you would like to where you would like to implement extended key update and do interoperability testing, please do reach out. We started initial implementations, and many of these changes are a result of attempts to perform these implementations and do interoperability testing, so that will help make this better. And I see Victor is in the queue.
Having listened to the same slides essentially in TLS yesterday, I'm wondering whether it makes sense to run these in parallel, or whether it really makes sense perhaps to sort out all of the core design issues in TLS and then bring this to Quic.
Right, that is effectively what we're doing in current text. So current Quic draft refers to the TLS as normative reference and says we're using exact same process, exact same labels. The key difference in Quic is that, of course, we have the luxury of the key phase bit that we can use. There is no such thing in traditional TLS, and particularly in DTLS. But when it comes to the key exchange itself and doing all this crypto work, Quic and TLS drafts are in sync. Okay.
It's really about timing. Does it make sense to be, designing and testing this if it still might get changed on the TLS side and then have to be redone here?
I believe it does, because, well, most TLS stacks that I'm aware of, they're not Quic exclusive. They do TLS for multiple use cases, for TCP and others. And also that will help, I hope, design APIs that would work for both use cases. So I personally believe that it makes sense to do this work in parallel at the same time for TCP-based TLS and for Quic. Christian?
Yes, I mean, how far are we from getting the verification and the proof that this is secure?
You mean the FAT, the beloved FAT process, formal analysis process, right?
Yes.
I think it is in the queue for TLS side. Now it's quite high up in the queue. I don't have time frames I could share, but this is an ongoing work. It does depend on initial implementations. So I really hope that we will get to that before the end of this year.
Yeah, I mean, basically, I would not want to do any kind of implementation work on my side until basically the TLS process has completed and this kind of formal analysis has been done. Because, I mean, frankly, it's a very hard requirement. You are partially compromised and you try to not get compromised again. And so it's entirely possible to get it wrong. And basically, I would very much like to see the process complete in TLS before we do any change in Quic.
Indeed, TLS draft is a normative reference for this draft, so this draft cannot possibly overtake TLS, and absolutely we expect FAT process to complete in TLS before progressing it to working group last call, let's say in Quic.
Thank you.
Hi, Yaroslav, Sean Turner, way in the back here. Just want to let you know that we did actually send the document, the TLS extended key update document to the FAT. So the process has kicked off, and we'll have to just wait to see if we actually get a response. And we can try to apply pressure, but we're basically asking for a favor. So thanks.
Thank you.
Kazuho, as a implementer who maintains a TLS stack, which is used both for TCP and Quic, I appreciate you bringing this draft in sync with the TLS side, because it helps us understand the designs and validate it, as you said. So thank you for doing that.
Thank you, Kazuho.
Cool, thanks. What I'm hearing as a chair, I'd say, is that we have a normative dependency on TLS, and that's where a lot of to me as not a crypto person, that the heavy lifting is being done, and that the authors are committed to keeping the document in sync, but that we maybe don't need to hear every working group meeting if there's nothing of note relevant to the Quic working group. So we don't need to spend too much time, but for the people who are like Kazuho wanting to actively track that work, brilliant. And for the folks who want to maybe wait for a while for it to settle down, they can do that too. So I think we're in a right situation here. As always, we need implementations at the end, and we'll get there one way or the other. So I don't think we need to worry too much about being in tight lockstep or trying to drop this because we're waiting on someone to do something. As a general implementer, again, speaking more individually, using Quic as a way to test other properties of TLS and things we're using to ensure that it is right. I would hate for the TLS working group to get towards the end of their process, and then we tried things, and then we realized that we are going to need to go back to them to ask for a tweak because we didn't try something. Okay.
Thank you, Lucas.
Cheers. Next up was Martin Seaman to give us a very brief update about the address discovery draft with no slides this time. So you can do it from there if you like, Martin.
Yep, it's a very quick update. We are basically done. We have a few editorial issues that we have PRs in flight for that are just waiting to get merged. And once that's done, we'll be ready for working group last call.
Okay, thank you for that update. If you have not read that draft, or you're thinking about doing so, now is a great time to go and do that. Next up, Ian, to talk about all the acts.
Oops, forgot to update the slides. Okay. We are not in San Francisco. It is not July. Anyway, let's move on. Is there? Never mind. Okay, so the frame formats have not changed dramatically since the last time we talked about this. The main change is the immediate ACK frame is now a 1-byte type. So that's probably the most notable thing. Next slide. The other recent changes are also fairly small. Again, we landed a change that said, when you do a probe timeout, especially if you're going to increase the reordering threshold, it's a good idea to send an immediate ACK with it to make sure your probe timeout gets a response as quickly as possible. There's also a recommendation about sending immediate ACK after a long idle period to get a new RTT sample quickly, and some other clarification text. So next slide. All right. Okay. So this is a little bit of a difficult one to write text for, and I welcome Kazuo and any others who have thoughts on this. But Martin Duke noticed when implementing this that when a previously quote unquote missing packet arrives, we always send an immediate ACK, which if you're dealing with sort of persistent reordering, ends up in a situation where you send fewer ACKs than RFC 9000 does, but more ACKs than you might hope, given the spec. Additionally, some of those ACKs are of questionable value. So for packets within the reordering threshold, they would only be sparsely declared lost if too much time passed. I'm not sure exactly what too much is, so unfortunately I don't have a good way to resolve that question, and my suggestion in the bullet I think is subtly incorrect, unfortunately. For packets farther away than the reordering threshold, they have already been declared lost, and so the only time it has value is if an immediate ACK arrives before the data is retransmitted. So maybe in applications like MOQ, where you might actually have a decent amount of data in the queue, this might avoid a spurious retransmit if the packet arrived just in time. But typically, this would kind of be a no-up by sending these extra ACKs. I know Kazuo, I believe, proposed some text. Do you have that on hand, Kazuo? Sorry, I didn't add that to the slides. I meant to. I think the question here is like, do we want to change anything? And if so, how prescriptive do we want to be? So we can do nothing. We could editorially call out this as a potential concern or behavior and say, do your best to optimize for your application situation. Or we could be prescriptive about saying like, should not send an immediate ACK if the packet that arrived is farther away from the largest ACK than the reordering threshold or something like that. We could say text about one or two of these cases.
Can I quickly hop the queue, because your last point, it's not only about retransmitting, it's also about congestion control. When you get the ACK and you know it was a spurious loss, you can open your congestion control window again. So there is a benefit.
That's what I was going to say. Well, on the last one, though, you would have already declared it lost. Oh, so you're saying you could undo. You could do the undo faster or earlier. Yes, you're right. The undo would occur earlier. Hopefully the undo would occur anyway, but yes, the undo would occur faster. You're right.
Kazuhoku, I think it would be better to have a should here because it prevents mistakes. And regarding the pull request I opened, sorry, I forgot to update it once I opened it, but I think it's now already modulo Martin Duke's comment that we have a one-off bug.
Yeah. I think this is the only one I actually wanted to talk about. So
does that give you enough to do something? Or Miri's coming back.
Yeah. Is Martin here? I don't know. Maybe not. Oh, I didn't know if you have. Miri, go for it.
So we brought this here because that is a design change. So currently, we just say if you receive a packet that fills a gap, you behave as you behave in RFC 9000, which is you send an immediate ACK. And now we're developing, or the PR is basic development logic that's saying if you also know about this reordering threshold, then you don't need to send an immediate ACK. You can do something else that we need to carefully specify.
Yeah.
So I just wanted to bring people's attention here that we're actually, maybe there was a time in the draft where we were actually not sure which of the two options we were actually going for, but then we clarified this in the last version where we said we don't change this behavior, we go with RFC 9000, and now we're changing it to something else. And I just wanted to make everybody aware.
Yeah, I think that's a great point. I probably should have put that on the update, but this sort of came out of the fact that we actually clarified what we were doing, whereas before I think it was ambiguous. Yeah. So, which, I mean, it's good. It's better to clarify now than later. Okay. This is a somewhat complex issue, so if people would like to engage with it on the issue, I will also try to write a PR to see what text people like, but it definitely takes a bit of thinking to noodle through it.
John, do you want to say something without being in
I'm
the
sorry,
queue.
I left my phone there, so I'm not in the queue. There, Duke is in queue for me.
Ah.
So is the point, and I can go back and engage on the issue here, but just to be clear, the whole point of the ACK frequency was to reduce the number of ACKs that were being sent. So if the receiver decides that there was a gap and got filled, and I'm going to ACK it immediately, the whole point of immediately ACKing that was in case the receiver had indicated a gap earlier. And in this case, it doesn't look like the receiver had indicated a gap earlier, right?
So I should have prefaced this. The receiver must have already communicated a gap for any of this logic to apply.
I see.
So if the receiver has never actually communicated the gap,
then it doesn't.
This is irrelevant.
Okay, good.
So
I just wanted to check that.
this is more the case of like, imagine you get a gap and then it happens to be you have a 10 packet threshold, and so you immediately send an ACK due to that.
Yeah.
Then now you have communicated the gap, and now like, what do you do? So if you happen to hit one of the non-gap threshold kind of things, then you could still communicate a gap fairly quickly in some circumstances. So
I understand. Thank you.
Corey.
Gori, purely as an individual, is this, what are we optimizing here? It's more robust just to send the packets, I guess, to loss of these ACKs and etc. Is that right?
It is more robust in some cases, although in the second case where you think it's probably already declared lost, then it probably doesn't really matter very much because, I mean, there's a minor delay in the undo process, but besides that, it probably doesn't matter very much. But on the other hand, if there's interest by a number of people who have expressed on the list, I believe, in experimenting with like allowing a bit more reordering in Quic. And so if we're going to allow kind of persistent smallish scale reordering, where smallish might be like, up to 10 packets in packet number or something, I don't know, something not insane, that could end up hitting this quite often where you send quite a few more acknowledgements than you kind of really intend to because of this logic. And so I think that's where my main concern comes in the practical realm. And I mean, if one option is we could run some simple simulations and see how bad it is, would that be helpful?
Well, there are a couple, I mean, how often does it happen when it's working right? And then how bad is it when you do it? And probably also how bad is it when you lose some of the ACKs, which is probably easy to add into that recipe.
Yeah,
I mean,
I don't know.
And then we could just make a decision because we need to move on, I think.
So, what was your, okay.
I said it would be good to do it rapidly so that we can just move on and close the item and publish.
Yeah.
That's the goal.
Yeah.
Mia Kulvin, I'm actually confused now. I thought we were only discussing the first case because A, as I said, the second case has a value, and B, the second case can actually lead to problems. If you have a very long reordering threshold and you never send an ACK, then this is actually kind of a negative impact without any reason. So like, if you already told the other end that there's a gap and then you receive a packet that fills the gap, you should always ACK. That's the second case. Send an immediate ACK.
Well, the second case, though, you think it's already been lost.
Exactly, but it might take it, but it's not lost, right? And
Sure.
And you want to tell the other end it's not lost, so you can read your congestion control. And if you don't send an immediate ACK, if you have a very long reordering threshold, it can take forever until you actually send an ACK that tells the other end it wasn't lost.
Or would it take I mean, when some of the other metrics like ACK delay or like the threshold should kick in, right?
At some point, yeah, but if it's very long, if you have long delays and whatever, it can really take. And we had an issue in that one. That's how we actually got into this whole discussion. There was an example case which was, or like if you don't send anything anymore, these kind of things, you don't send anything for a while, and I don't know. So actually I don't think that's a good idea, and I don't think that was the case we were discussing. I thought we were only discussing the first case where you didn't tell the other end that you might have a loss, and then you fill the gap, and then RC 9000 would still say you send an immediate ACK, which is useless because the other end didn't know that there was a gap, so nothing will happen.
No, the draft already is correct on that. The draft already says, like, if you have never sent an ACK that reports the loss, then none of this like applies.
It doesn't.
Okay, well then that's a problem.
But that's what we're discussing.
Well then we should just fix that.
Because the reason is,
But I thought it did.
no, that's where the confusion comes from. But the
Okay, well
reason
then-
is that having a reordering threshold makes sense because it reduces your ACK load by quite a bit, right? Instead of ACKing every second packet, you can ACK every 10th packet, whatever.
Sure.
So that makes a real difference. If a packet get lost and you get it and whatever, sending this one immediate ACK, it might be useless, but it's not like a big difference. It doesn't make like a huge amount of load or whatever. So at some point we said we don't change the behavior of RC 9000, we only would change the behavior for the actual ACK behavior. And that was what the current draft says.
Yeah, Jen Iyengar, this is what I'm understanding as well, is that the problem that I came up earlier to talk about is that this is the example case. You received 1, you received 11. You don't report a gap, but now you receive 2. And you send an ACK. You receive 3, you send an ACK. You receive 4, you send an ACK. That is something we definitely do not want for 2 reasons. 1, that is terrible ACKing behavior. 2, it is actually not an uncommon reordering case where one packet goes ahead of a bunch. That happens. It in fact happens in the small packet case where the tail packet races ahead of everything else. And so that is one we should absolutely fix. The second one, I really don't care that much about. I think it's okay if we fix it. If it's hard, I think we should keep it simple. But the first one we should definitely fix.
Okay.
Yeah,
That's
and that's fine. Like we can change the behavior. I'm just saying that it's a change from the current draft.
I don't think we're going to resolve that right now because I need to go.
No,
back
that's
to it.
fine. But the second one, it's not only a change from the current draft, it's actually changing, I think, a decision that was made in RC 9000, which I don't think we need to change.
Okay. Thanks. Okay. Well, 3 of us or multiple of us can sit down and sort this out.
Martin, are you actually in the queue, or was that a Jana proxy again?
No, I'm actually here. Martin Duke, Google. Right. So, if I understand correctly, in the scenario, much like Jana proposed, if you get 10 and then 1 through 9 in RC 9000 land, that is 10 ACKs, and I think we all agree with that. With the if you use the ACK frequency draft and your ignore order is infinite, and your desired ACK frequency is 10, you will get, if I'm not mistaken, 9 ACKs, which is like about 80% more than you might have hoped for by sending an ACK frequency of 10. So this is still strictly better than 9,000, but as John was saying, maybe not what we were shooting for. The other comment I wanted to make was a little more, I think this comes up in this issue, but a little more broadly, because I found some other issues and then closed a few. But I find it very hard to reason about the case where people have very high reordering thresholds and very high ACK frequencies. And there's potentially some weird emergent behavior there. And maybe this is a doctor don't do that situation, but I wonder if we should do some thinking about that, if there should be some guidance in the document. And I can't be more specific than that. Sorry.
Okay. Yeah, I can imagine that. But yeah, I don't have anything in mind.
I think one example, just to make one, is with the trimmed ACK ranges one, that if you have one of these extremely low ACK frequencies for a variety of reasons, and you have lots of ACK ranges because you're having a bad loss pattern, that you could actually never report certain packets, which seems bad. So if there are lots of individual packet losses, then I might have, say, 300 ACK ranges, right? And if you set, there's certainly legal ACK frequency settings where you would never send an ACK in any of that. And if that happens, you could actually end up truncating that ACK and never report certain ACK blocks. Just an example of a weird pathological thing that can happen with silly numbers.
I don't think that was the intent of the draft. I think the intent was to still use the RFC 9000 rule that you gotta act everything at least once, but we might need to repeat that in this draft.
Yeah, I think someone pointed out that like technically there's a line in there somewhere, but that seems like really subtle for an implementer to say, because this could never really arise in 9000 because you report every time there's reorder, any sort of gap, which is reordering, et cetera, and you should act every other packet, et cetera. This could never, with any reasonable number of max act ranges, that could never happen, but now it can. So this is the kind of thing that I think I could come up with more, but this is the kind of thing I think we should do a little bit of thinking about these limits that are legal in the draft.
You said, just a clarification, you said low ACK frequency, which means you would set X very often, but you mean if you send them very rarely, right?
Well, low frequency means few acts. Sure, if the ACK frequency index if the number is big in the frame, then then you can end up in a situation where there are lots of ACK ranges that are never reported. Potentially. Just an example. Thanks.
Yep. Thanks, Martin. I agree. No, we should clarify that if it's not so.
Martin, does that need a separate issue so that we don't forget that what you just said? Because I don't actually think that's really recorded in the current issue.
There is, in fact, a separate issue. I think it's one of the two issues open, if I'm reading GitHub correctly, but I don't always do that.
I didn't put that in the slide mostly because I was like, I just need to write text to make sure this is clear.
Okay.
Yeah, and there's some more. Yeah, and there's some other thinking around this that I think we should do. Like more people than me should probably be mulling what happens when these numbers are huge.
Cool. Next. Next presentation? Or?
Yeah, I think we can move on.
Sure.
More acts.
All right. So Quic packet received timestamps. So there have been a number of updates. The core goal of the draft is the same, to enable the peer to report received timestamps for some or all ACK packets. This is particularly useful for congestion controllers, which are oriented around like real-time communications. Goog, CC, and others use feedback like this today. The current format is relatively straightforward in the scheme of things. So it's a packet delta from the largest acknowledged packet, and then how many timestamp deltas there are, and then a series of timestamp deltas. So next slide. The main change since the last version was we always include the received timestamps section in an ACK once you negotiate it, i.e. in one RTT packets. So this costs a byte if you, for some reason, don't put any timestamps in your packet, but if the peer is negotiating the timestamp option, and so are you, then presumably they want timestamps in their packets, so like it shouldn't be 0 very often, I wouldn't think. This is quite straightforward and kind of simplifies some of the things from the previous draft. We changed the format to support out of order packet number ranges. So you can have a series of ranges that do not have to be in packet number order. Add some examples. We proposed a approach for coexistence. We'll talk about that later. It's probably not exactly the right proposal, but at least it's a start. So next slide. Okay. Yeah, let's dig into this because probably this is the most substantive issue here, which is there's current text on how multiple ACK frame extensions coexist. I proposed using the RFC number as a tiebreaker. I believe someone earlier today pointed out that if you have a BIS, do you really want the extension to move? It's a very good point. We also can just make extensions reference previous extensions and say, I'm after this one, which is kind of what other extensions to things have done when they kind of build on other systems, or something else. I mean, I think I would like to resolve this, but I don't have a strong preference as long as we think we can get like a fairly stable and strict ordering, and it's not overly difficult for implementers. Jonathan.
Yeah, Jonathan Maddox. I was the one who pointed out the thing about the BIS. Yeah, I mean, it seems like, is it possible to have an IANA registry for a total order?
Sure.
Or everything gets a number which never actually appears on the wire, but the IANA registered number determines what its order is?
Yes. Is that better than just putting it in the draft? I don't know.
mean, the thing I'm worried about is, I mean, what happens if, you know, you've got multiple drafts in flight at the same time, you have to decide who goes first, and in particular, what if somebody wants to do a proprietary extension to this?
The latter one is probably the more like concerning one to me, which is like, I'm not that concerned about too many drafts in flight at time. I think that's manageable, but you have some proprietary extension, where do you stick it? Is a real concern. Because I'm sure that will probably happen.
Yeah, I mean, the other alternative, which is also awful, but might make it, I guess the other thing I'm worried about is this is going to be lots of fun for things like, you know, well, I guess Wireshark's never relevant, but is QLog going to be able to handle this?
For what? Sorry?
Are QLog traces going to be able to interpret this without a lot of help? I mean, parsing what's in that packet.
Why would they have because they'd still be able, like the QLog tool would have to know
But
which
ones are
frames
enabled,
exist,
yeah,
right?
yeah. I mean, I'm just wondering, it's less efficient on the wire, but almost wondering if you want to have like a recursive container type. So this is a container that lists explicitly, hey, this is subtype 1, subtype 2, but maybe that's also awful.
That's kind of what, along the lines of what was ripped out of this draft, which was like a generic ACK frame that could be extended by itself. But I think the working group last time was pretty strongly opposed to that approach and wanted to keep consistent with the RFC 9000 approach of new frames, get new types.
Now, in that case, I would say, if you want to do it by order, I'd say have an IANA registry that gives a number that never appears on the wire, but just determines the total order of the ACK extensions, rather than try to do it by RFC number, which is transient, as we determined.
In retrospect, the RFC number was problematic. Thank you for pointing that out. Kazuo.
Kazuo, do we even need that order?
I mean, with the number of extensions we have now, we don't need it.
Right. I mean,
Like-
it can be in any order. Couldn't it be, because if you look at TCP options, they add many ordering and we are fine with that, right?
Yeah, I mean, right now we just reference the one other extension draft and then.
I mean, I'm saying that this current text is fine, modulo requiring the extensions to have a particular order, so we can just strike that. The requirement for the order.
Sure, I mean, that would also work, yeah.
Mirkulivin, I actually thought we discussed last time to not do it, to not extend the egg frame anymore, rather define a completely separate frame that is independent of the egg frame. And for multipass, it's different. Saying as a multipass, and it's too late anyway.
Except for my draft.
and it's too late anyway because it's really kind of impacting the path, right? So there's really, it's extending this model of the path that we have in RFC 9000.
Yeah.
But like for future extension that just want to add like one piece of information to the egg frame, you can also just use the last packet number and create a new frame and say, when I receive this packet, I have this timestamp and it's new frame, it's independent, it's good. We don't need to talk about extensibility at all. And I thought that's what we discussed last time.
I think there was some mention of that. I mean, I certainly don't have any other use cases where like having the information integrated into the actual ACK frame is important instead of just shoving it in a different frame. Like I haven't come up with any, but yeah, so I mean, that supports your point.
And I believe there, I mean, if it comes up in future, we can discuss it again, but generally those cases are very rare and maybe there's not any further case beside multipass in future.
If there's, again, if there's a small enough number of them, it doesn't matter because there's like one at once and you just write some text in the draft about what to do. So, which is, I think, what very on what Kazuo said, which is like strike the bit about the RFC number and move on. So, yep.
I even meant those cases where this option that you just do a separate frame doesn't work are very rare, which is like, I think multipass would have been much more complicated if you didn't want to touch a egg frame. But I think for other extensions, just defining a new frame should like always work.
Yeah, you're good.
John?
I think I'm just going to violently agree with striking the RFC number from here, leaving the future problem to future proposals, because there isn't a fundamental issue here. I disagree. I think we should not worry about this general extensibility problem here.
Lucas Pardew speaking as an individual. Something I'm working on is a draft on extensibility and deployability of protocols for the IAB work. And I'm kind of worried about setting up some generic extensible thing with more IANA registries, and we don't actually exercise the extensibility of that. In those discussions, Quic is kind of unique different compared to something like HTTP3, which has more extensibility that is ignored by default. In Quic, we tend to be quite rigid and robust with the precise frame formats, and if they're wrong, it's clearly a broken peer and close the connection, and you need to negotiate which frames you're sending up front and those kinds of things. So I don't have any answer here, but I know what I don't like, or that I'm worried might cause us unintended consequences later on.
Yeah, sounds good. I mean, worst case, we can change our mind in the future if we really hate this decision, because all we're saying is like where it comes relative to the current ACK frame and multipath. And after that, some future universe can change their mind. So this is not fixed in stone forever. Sure. In that stead, I believe the current format is compatible with MP-Quic. And so I guess the only question is like, is there more text I need to add to the draft about how it's compatible? I mean, it seems pretty obvious. MP-Quic ACK frames come at the beginning, or the infrastructure information comes at the beginning, not the end. I don't know. So if people have editorial suggestions on how to make it, if they would like me to make it clear in some way, shape, or form about the MP-Quic bit, tell me. Otherwise, I will just close that issue as done.
Jonathan?
Yeah, I think I was sort of responding to Miria's suggestion about just putting new information in a new frame. I think architecturally, maybe that's cleaner, but the problem is what happens if those frames end up in different Quic packets? And then you can get in a situation where you have partial information about some packets, so you know, like, whereas, yeah, but not any different partial information about other packets, and that's probably very confusing if you're a congestion controller.
So we've tried to be very conscious about only putting things in the ACK frame where like the congestion controller really wants to know all these things at the same time, whether it's ECN or timestamps.
Yeah, that's that's I think, so putting it all in the same frame is probably a necessary thing here, which I think Miria was talking about doing something different, but maybe I misunderstood her.
Yeah, because I actually think this is two independent information. So if you create a separate frame which doesn't have the ACK ranges, but only tells you, I received this packet at this point of time, then it gives you a timestamp that's also gives you, and you can use that, and it doesn't acknowledge any packets at the same point of time. And the acknowledgement information is just a different set of information, and this is actually independent. I mean, if you have them at the same point of time, it's probably like as soon as you have any of these information as you can get them, the sooner you can react to it, but the information itself is actually independent.
Yeah, it is somewhat, but how you process it is, I mean, congestion controllers like to have all the information for about a packet at once. So.
No, because the congestion controller is not so much interested in packet loss, except to make a decision that you have to reduce your congestion window, which is usually the same point of time where you decide that you lost the packet, and then you tell the congestion controller, you have to reduce your congestion window, and then you apply this logic. While the timestamp is actually something that you feed into your congestion controller on a continuous basis in order to decide also how you increase or actually only how you increase your congestion window, usually in many cases. So it's really two pieces of independent information. Just because they all depend on the same packet that you might receive, it's still kind of independently processed. So let's not like make it more complex than it needs to be.
Okay. I think this is all I had. Did I have? I can't remember. I might have had something else.
Christian, do you have a comment?
Oh, sorry.
Yeah, two things. I mean, first, to Mia's point about congestion control, I like the timestamps. I mean, I tried to get the timestamps before. It's interesting, and I applaud the effort to make it work. No, I was on the queue for something else. Please don't call anything MP-Quic.
Oh, what was it called now?
Okay, noted. It is the multipath extension to Quic. It is an
Or
extension.
if you want something short, call it Quic Multipass, but don't call it MP Quic because it's ambiguous and it refers to an old way of thinking. We don't have a new protocol that's called MP Quic. We have an extension to Quic.
Okay, I can make an editorial adjustment to not refer to it as that. Thanks. I'll file an issue for that.
Very quickly, the comment about whether to put the info in the frame or not, it just makes me weird because like we're all about how frames are packed into packets as under the complete sender's control, and you know, frames have to be completely contained in packets. So this seems like something resolvable to me, rather than having to shove everything into a single frame. But whatever, it doesn't matter. We're kind of over time.
Yeah.
So,
okay. I think I'm done anyway, or at least this is the issue I just wanted to discuss. So thank you.
Thank you.
What do you want to say, Mira? You can go ahead. Just if you're going to say something.
Did we solve the issue or not? I'm not agreeing to just close it without action.
Yeah, I think we're going to nuke all the stuff about the RFC number thing and just make it clear about how this extension coexists with both the existing ACT frame and the multipath or the Quic extension to enable multipath or whatever. The thing
So I agree that we definitely don't need this text, but I would like to redesign the frame. I would like to redesign the frame.
I don't want to redesign the frame?
Yes, so we don't have agreement here, right?
Well, but this isn't about redesigning the frame.
No, but this is how you solve this issue.
Which issue?
The issue that it needs to be compatible with multipath Quic.
It's already compatible with multipath Quic.
But I want it to be compatible in a different way.
Okay, I think.
Okay, that's a totally different issue than what this was.
I think maybe open.
I open a new issue.
Open a new issue for that. Especially since if you want to redesign the frame. What's next? Yeah, next Kazuho is going to talk about the aforementioned potential directions for QMUX with just a reminder, this is not adopted work. Also, there's a pending recharter going on, but we still think that it's useful to cover this given recent findings.
Right. So next, please. So as a reminder, we haven't recharted yet, as Lucas pointed out. So we are just going to provide information regarding various proposals that's being made for the wire protocols, so that once the charter is being updated, we can have an informed discussion of which approach to choose. So next, please. So I've heard at least 4 approaches regarding how we do QMUX. And one is do it over web transport over H1. And the second one is do web transport over H1 without the HTTP request response exchange. And the third one is to send Quic V1 frames directly on top of a bidirectional byte stream. And the fourth one is to send V1 frames which are encoded within a packet, Quic packet that's sent over a TCP stream or the bidirectional stream. So, and for reference, there's Quic V1 at the bottom so that you can compare what's the difference between these 4 approaches. So if you look at the frame encoding, the first 2 options use capsules as the basis of encoding, whereas C and D, the latter 2 uses Quic V1 frame encoding. And if we consider negotiation, web transport over H1 uses HTTP header for negotiating things such as initial flow control credit. And the other 3, capsules, V1 frames, and packets use Quic V1 transport parameters for exchanging the transport parameters. And the established latencies like this, I'll cover them later. And then the recall layer, which is the unit of encryption that you apply when the substrate is insecure. The first 3 options rely on TLS. And the fourth option uses TLS for generating the traffic encryption keys, but reuses the Quic's encryption scheme for encrypting it.
So before anybody jumps in the queue, I just will note that there are going to be slides on each of these, so you can save clarifying questions for later.
Thank you. Next, please. So let's dive into the first option. Next, please. So this option that sends web transport, that does web transport over H1 is like this. So web transport over H2, as we know, is a way of carrying quick semantics over a single HTTP2 stream. But HTTP2 has lots of complexities that we don't need when all we need to do is run a single quick session over TCP or whatever. So for example, we don't need HBAC. We don't need header compression. We also don't need the H2 stream multiplexing because in contrast to web transport over H2 that supports running multiple quick sessions on a single connection, in case of QMAX, we only need to run one quick session on a TCP stream. And the third difference is that, and the third aspect of this approach, web transport over H1, is that it incorporates datagrams and research streams into the core design. And that's because web transport is something defined on top of Quic with these extensions, and web transport over H2 is a way of encoding it. So that's the way it has evolved, and so it has these properties. Next, please. So let's dive into the frame encoding. Web transport, as I said, uses capsules. It's a type length value encoding defined by the HTTP working group. And one property is that it allows endpoints to send unknown capsule types. If you receive a capsule and the type is unknown, they are silently dropped. And all the frames defined in Quic have a counterpart that's defined in web transport over H2, and the encoding is defined using capsules. And because all the capsules are a type length value format, even the frames that are self-delimiting, for example, max data that carries only one variant, has a length field. Next, please. So one of the advantages that web transport over H1 leverages from the fact that the underlying substrate is being reliable and in order is that it omits the length field of stream frames because the receiver can determine the offset by calculating how many bytes it has already received. And similarly, sending reset string capsules for a closed stream is prohibited because you've already closed a stream, so why would you send a reset stream after that? Similarly, sending multiple stop sending frame capsules for the same stream is prohibited because if you've sent one, you know that it would have arrived. So there's no point in sending multiple information. So web transport over H1 makes these kind of tightening the stream state machinery by leveraging the fact that the underlying substrate is reliable and in order. Next, please. So how do we decode frames? In case of web, because the underlying substrate is byte-oriented, endpoints may receive partial capsules. And if you receive a partial capsule other than stream, receivers buffer and wait until a complete capsule is received by looking at the length field. And because every capsule has a length field, right after the type field, this buffering and waiting for the complete capsule can be done in a type agnostic manner. And after receiving a complete capsule, what the receiver does is receiver passes the capsule payload. But because the capsule payload might be truncated or it might have junk at the end, you have to detect that and report a protocol violation if the payload is actually truncated or has some junk at the end. Next, please. And for stream capsules, there's an exception. So instead of buffering the entire capsule, receiver streams a payload of stream capsule to the application before the entire capsule is received. And this is mandatory because the size of the capsule is unbounded. So unless you do this streaming thing, you might run out of memory. Next, please. And regarding connection establishment latency, it takes 3 round trips, because in the first round trip, you do the TCP SYN exchange. In the second round trip, you do the TLS handshake. And in the third round trip, you send the HTTP request, and the server sends the HTTP response. And that contains the initial flow control credits that the client can use. So it's only after the client receives the initial flow control credits in the HTTP response that the client can send the first application data. And for what's worth, Web Transfer over H2 avoids this problem by using H2 settings to communicate the initial credits, but we don't have settings in H1, so this is why it needs 3 round trips. Next, please. And regarding the record layer, for what's worth, the record layer is the unit of encryption that's being used when the underlying transport is insecure. And in case of web transport over H1, it runs on top of TLS. So when the underlying substrate is in fact secure, like Unix sockets, we can run the exact same protocol over that secure substrate directly, avoiding the cost of encryption. Next, please. So let's go to the next approach, which is capsules. Next, please. So it's similar to web transport over H1, but avoids the use of HTTP request and response cycle. So once the handshake of the underlying substrate is complete, each endpoint sends the transport parameters immediately. Next, please. So, and regarding frame encoding and decoding, it's exactly the same as web transport over H1. Next, please. And establishment latency is reduced to 2 round trips, because now the server can send the initial flow control credits as the 0.5 RTT message alongside the TLS handshake. Next, please. And the record layer is exactly the same as web transport over H1, meaning that you can use it either with encryption by running on top of TLS or without TLS, without encryption if the underlying substrate is secure. Next, please. So what uncertainties do we have for the capsules approach? There are several questions. First one is that, do we want to depend on the capsule registry managed by the HTTP working group? I mean, in case of web transport, it's a protocol that's being built on top of HTTP, so it makes sense to depend on a registry that's being managed by HTTP. But the question is like, this row capsules approach doesn't use HTTP, so should we still depend on HTTP? And how are we going to manage the registry? And the next question is like, do we want to retain the divergence of web transport over H1 or H2, like tightening the stream state machinery? We could do that, but I mean, if we consider the basis of the protocol as V1, then it's a diversion. Next, please. So the next approach is the V1 frames approach. That was my draft, and it's now a different name, but it's the one that reuses the V1 frames. So next, please. So the idea is to send quick V1 frames directly on top of a reliable and in on the substrate while retaining quick V1 as much as possible. So instead of using capsules, it uses quick V1 frames as is, and the stream state machinery is also exactly the same as what we have in Quic version 1. And the first frame that's being sent by each endpoint carries the transport parameters. Next, please. So as said, the frame encoding is exactly the same as Quic V1. But then the question becomes like, how do you determine the length of stream frames without an explicit length field when it's a byte stream, so there's no packet boundaries? So to fix this problem, we introduced a new transport parameter called max frame size. So if the stream frame being sent omits the length field, the length of that stream frame is this transport parameter. And the default value is 16 kilobytes so that it matches the size of a TLS record. And for each stream frames are always sent in order. So even though there's the offset field, it's always in order and there's no buffering or reassembly required. Next, please. So let's go to how we decode frames in this approach. As we discussed previously in the capsule side, endpoints may receive partial frames as the underlying substrate is byte-oriented. So what the receiver would do is when you receive new bytes, you call the Quic V1 frame decoder. And if the frame is truncated, meaning you've only received a part of the frame, then the receivers retain the input as opposed to the V1 frame decoders generating an error. So it's about reusing the Quic V1 frame decoder, but generating a different error when it's truncated. And when more bytes are received, you append the newly received bytes to the buffer, and then you repeat the process of decoding the frame, or decoding the frame speculatively until a complete frame is received. So the benefit of this approach is that you don't need to have a dedicated logic to handle frame truncation. Next, please. And as an optimization, receivers might also stream the payload of stream frames, as we discussed in the capsule side. But this is a optimization, an option rather than a mandatory requirement in the V1 frames approach, because max frame size is set to 60 GB, and if it's as small as that, it's going to fit in a TLS record, which is decrypted atomically. So there's no point in doing streaming behavior unless necessary. Next, please. So what about the establishment latency? It's the same as capsules. Next, please. What about the record layer? It's same as capsules or web transport over H1. Next, please. So what are the uncertainties that we have in this approach? The question is specifically about the stream frame encoding. Do we want to omit the offset field because it's unnecessary? And the next question is, do we want to prohibit the use of stream frames without an explicit length field? Because as I said, we could use the transport parameter to infer that length. Maybe it's easier to just forbid the use of stream frames without a length field and always send it explicitly. Next, please. So let's go to the fourth option, which is use V1 frames and also packets. Next, please. So the idea, if I understand correctly, is that you send quick packets over the underlying substrate, and you do the encryption by yourself, reusing what we do in Quic V1, as opposed to other proposals that rely on TLS as the underlying substrate. And for each stream frames are always sent in order similarly to the other proposal, so there's no need for buffering or reassembly. And offset field of the stream frames can be kept, but it's going to be pure redundancy as the V1 frames approach. Next, please. The benefit of this approach is that by sending packets, we retain the packet boundary. So you have to, even though you have to buffer the packet, but once you go to the moment of decoding frames, you are guaranteed to have a complete frame. So there's no need about looking at the length and waiting for more data and those things. Next, please. But to paraphrase, we are shifting the requirement for buffering partial data from frame level to packet level. So because the underlying substrate is byte-oriented, you have to somehow communicate how large the packet is and buffer the packet payload until you receive a complete packet. And the problem here is that some packet formats of Quic V1, specifically the short header packet, doesn't have a length field. So if we are going to apply this approach of reusing quick packets, we have to change the design or adjust the design of Quic V1 packet format so that short header packets would include a length field. And similarly, there's questions about if we need the connection ID field at all when we have when the connection is the underlying substrate. And the other question is if we need to communicate packet numbers as well, because we can always infer the number. Next, please. And regarding establishment latency, it's the same as other proposals, modular web transport over H1. Next, please. And regarding the record layer, as I said, this proposal is about doing your own encryption like Quic does. And it works when the underlying substrate is insecure because you nevertheless need to encrypt somehow. So it's either relying on TLS or doing it yourself. But for deployments that use secure substrates, the problem is that there's no way of actually avoiding AEAD because Quic doesn't allow you to run without encryption. So we have to either tolerate the cost of doing encryption for no reason when the underlying substrate is secure, or write a separate specification saying how you use this approach without encryption. And the difficulty here is that TLS 1.3 nor Quic v1 defines a no cipher. So it's going to be, it's not going to be that easy to define a variant that avoids encryption. Next, please. And the other problem, other downside of this approach is that encryption offload might not be available because the AED structure is neither TLS nor Quic v1 over UDP that the offloaders assume to be. Next, please. So to summarize the uncertainties of this approach, there are basically two uncertainties. One is that we have to tweak the packet format somehow. And the second problem is what should we do with the deployments that use secure substrates? Next, please. So let's recap the complexities. Next, please. As the title of the slide says, I'd say that the complexity, how you think each approach is complex, depends on your perspective. So if you're coding a QMAX stack from scratch, I'd probably say that B, the capsules approach, or the C, the V1 frames approach, is the least complex. The frame encoding is different. The state machinery is slightly different, but they are roughly the same. And compared to those two, A, the web transport over H1 is more complex because you have to do HTTP, or D, the V1 frames and packets approach is more complex because you have to do the AED yourself. But if you are coding on top of Quic v1 stacks, if you are implementing QMAX on top of Quic v1 stacks, the situation becomes different. I'd say that either C, V1 frames, or D, V1 frames and packets, are the easiest to implement because we are reusing lots of Quic v1 compared to the approaches that use capsules. And conversely, if we are to, for the people who are going to implement QMAX on top of web transport over H2 stacks, obviously the easiest option is A, web transport over H1, because all you need is to port web transport over H2 to H1. And the next easiest one is do capsules directly. So so the complexity really depends on how you want to approach the problem. And the final row talks about the uncertainties that we've discussed for each approach. And I'd say that obviously web transport over H1 has the least uncertainties because web transport over H2 is now reaching its final phase. And probably the next one that has the least uncertainties is the V1 frames because we know the aspects. The only uncertainty that we had as discussed was the stream frames. And compared to that, in the capsules approach, there's the uncertainties around the registry or how we tighten the stream state machinery compared to V1 on that. So there are those kind of nuances. And probably D is the most complicated because it requires the design of the packetization layer. So that's the summary regarding the complexity of the approaches. So next, please. So going through all the options, I think there are possibly like three questions. The first one is, which frame encoding do we want to use? Do we want to use capsules or Quic version 1? And the next question is, how much do we want to diverge from Quic version 1? Do we want to omit the offset field of stream frames because it's redundant? Do we want to tighten the stream state machinery to prevent use of the redundant frames? Or maybe we don't just care? And the third question is like, do we want to just use TLS as a substrate, or do we want to pull the packetization layer of Quic V1 to QMax and do our own encryption? So I think these three are the main disputes behind the four approaches being proposed. So thank you for your time.
Just a quick chair interrupt before we go to the queue. Thank you very much, Kazuo, for going through all of that. Lots of details. We have, I see, 8 people in the queue and 7 minutes remaining. So as a quick reminder, this is not about, we have not adopted this work yet. We cannot talk about which protocol we want to pick for QMux, but if you have comments to make very quick clarification, we will not have the time to have a back and forth. So please be brief, everyone. Tommy?
Okay, Tommy Pauly, Apple. Quick clarification question, just to understand for the packet version. I understand that it's more complex and has other trade-offs. You're talking about the CID being redundant, and I certainly understand that the CID would be redundant on every single packet if it's not changing. However, it seems like one of the attractivenesses of this option is that like maybe you could do migration from another connection, at which point you would want a CID. So do you imagine that there'd be a CID somewhere so that you could recognize that this is a session you've migrated, or is that just off the table?
I mean, I think so. I agree that there's that kind of option of migrating from TCP to UDP or vice versa. But I think the question is if we want to do that, because it's going to have a lot of uncertainties.
Okay. But does it seem like the packetization option is probably the only one that's practical to migrate with?
Well,
That's a question.
Well, I'd probably say that you could migrate the stream states. So either approach would work.
Alessandro Ghedini, Cloudflare. Thank you for the presentation. It actually clarifies a lot of the thinking that I had and the benefits and costs. From an implementer perspective, even I'm not necessarily sure that the web transport, like even if you already had a web transport stack, the capsule implementation might not necessarily be easier because you still have to implement all of the quick framing again from scratch, right? So as a quick implementer, the benefit of this would be, oh, I can actually use a lot of the code that I already have, versus if you use web transport, you could potentially define completely new captions, right? Not necessarily follow the format. And for similar reasons, already having a quick implementation, the solution where I can make the least amount of changes to my implementation would be the preferred one, which is, I think, C. And even with some of the questions with like omitting fields or slightly changing the packet header, I'd rather we didn't do that because it's easy to skip parts of the protocol, like skipping the packet header or skipping the encryption, but then slightly tweaking existing formats is a lot more complicated. And even if it's not necessarily needed, I'd rather leave those parts as is.
Thank you.
Ben, and reminder to speakers, please be brief.
Okay, one, if option, I think we should make sure that option D is in the new charter. It's not clear to me that it is currently. So we should get clarity on that. And I do think that actually implementing option B from a web transport implementation would really be trivial. Maybe a difference of opinion with Alessandro. I'm very scared by the idea of trying to integrate this logic into a Quic engine that also has to like be working for Quic.
Thank you. Jana?
Jana, I'm gonna...
Just before, sorry. Regarding if the V1 packets option D is out of charter, my recollection is that we tried to keep that option in charter because there was the discussion around that.
Jana Iyengar, Netflix. I wanted to basically just very quickly have opinions on the options. I'm not going to go into them here. I think C is best, but I think it's important to actually frame what problem we are solving here. At the beginning, when we started talking about QMux, it was about using existing Quic code and Quic semantics to support basically HTTP3 semantics on top of TCP without having to do some additional lot of writing of code. And if that has changed, we should bring that up, because I think the slide that he had before this about like depending on the perspective, I think that is crucial to getting traction on this question. That to me, I know where my biases lie here, but I think this is probably the most important question to get clarity on.
Thanks for the feedback. Something we need to keep in mind. Alan?
Yeah, Alan Frendel, Meta. Thank you so much, Kazuho. This was a great presentation. Really appreciate the detail. I think maybe to echo just what Jana said, it's that we should think about how important is it, this code reuse angle, and I think it very much does vary by, I have both a Quic v1 stack and a web transport over H2 stack, and I agree with Ben. If I'm gonna do this, it'll be way easier to do it with the other one. And when we built web transport over H2, we spent some time thinking about, because we pulled all these frames from Quic, and I think at that time I was like, let's not change them. I want to reuse my Quic parser. But I don't know, the ship kind of sailed. So we shouldn't necessarily be making a bunch of decisions about a protocol that will live a long time based on the state of implementations right now. So we should just think about what do we want the protocol to be.
Thank
you. Ian Sweat, Google. Yeah, thanks for the great talk. I think a key concern I have in mind is like performance and what is going to perform better in the long term. I'm actually kind of willing to entirely re-implement my Quic parser, whatever, that'll take me like a week and Matt a day. And so code reuse is nice, but it's not absolutely critical. At least at this layer, at the HTTP3 layer, it's much more critical because it's a lot more code, and like that QPAC and all those things are really complex. So like being able to reuse those is absolutely critical. But at this layer, it's not really that much code. So, but performance is key. So, if I'm going to use this in the data center, if I'm going to use this in those environments, then, being at least reasonable about the overhead, both in terms of bytes matters, but CPU probably matters more. Yeah.
Thank you.
Mira?
Mia Kulevind, just on your first question was, should we use frames or capsules? And like, I think we should use frames in this working group because this is a quick working group. I don't see like benefits, but so that just to try to answer or give you a perspective on one of the questions. But my actual question is for solution A, and I'm not arguing for it, but I just want to understand, we're nearly there, right? There's not much missing. If you just look at web transport, it's really minimal what you need to add, right?
Yes.
Or what's the part that you need to add? What's still missing there?
What's missing is so web transporter over H2 only talks about H2, so it doesn't tell you how to run it on H1, even though you can.
Okay. But effectively, the web transport working group could do that anyway, no matter what we decide here, right?
True.
They could, but that's another question, and it's something we need to consider. I did lock the queue. We have 3 people in. I would like to hear their perspectives if they can be very, very brief.
Sure. My first observation, very quick, is that the problem with D is that unlike the first 3, you cannot multiplex it with other TCP-based TLS applications. So I think that it would make it not useful for a lot of use cases that people have in mind. From my personal perspective, as someone who implemented web transport over H2 even partially, the hardest part is not the framing. The hardest part is the logic of how you multiplex multiple flow controlled streams over basically another flow control stream. And most of the logic I had to write deals with things like buffering and prioritization and not framing, because as far as at least in my personal experience, framing is mostly trivial.
Cool. Thank you. Christian, quickly.
But my perspective is that we need a solution for the case where we are running an application based on Quic, but the local network will not let you do UDP. And if we do that, then basically the priority is running QMUX over TLS over TCP. And if you cannot do a direct TCP connection, running QMUX over TLS over HTTP connect. These are the very, very simplest way to do that let's get out of the UDP blockage problem. And I'd like to see that supported in the description.
Okay, let's move on. Thank you, Christian. Marco, the final 2 words.
Hey folks, Marco Munisaga. So I'll just mention a couple things. So on C, I implemented C. I think that was pretty straightforward, and that's definitely my preference of the options. On D, I would be afraid to see us have to make a future spec on how to make Quic v1 packets work without encryption. And then just as a general note, I feel like web transport is, in the overview, it talks about how web transport is designed and constrained by the web security model. So that's just something we should keep in mind for solutions that are built with web transport. Also, that was great. Thanks, Kazuha.
Thank you.
Okay, thank you everyone, and sticking to the guidance that we gave you at the start. Thank you. Up next, we have as time permits bucket now, talk on deadline aware quick streams from Tony. Tony, go for it.
Good afternoon, everyone. I'm Tony John from the University of Magdeburg. My talk is an idea on doing deadline-aware streams in Quic. Next slide, please. This work evolved from our research on DMTP, which is Deadline-Aware Multipath Transport Protocol. We had a few discussions about this in the mailing list, and we had this draft published based on the feedback that we got. Next slide, please. Why do we need deadline-aware streams? As we know, modern real-time applications need strict latency bounds and predictable performance. The use cases are usually teleoperation, telesurgery, and online gaming. With the current Quic streams, they don't have any awareness of time constraints, and this could lead to bandwidth being wasted on expired data, head-of-line blocking on streams with stale data, and wasting bandwidth on retransmitting all the lost packets that won't make it in deadline. So we would need the transport layer to be aware of these deadlines. Next slide, please. How does deadline-aware streams fit into Quic and Quic multipath? With standard Quic, we don't propose a protocol change, but we have recommendations on sender-side deadline-aware scheduling by leveraging the existing stream priority mechanism. With Quic multipath, we propose minimal extensions to do path selection based on deadlines and strategically sending ACKs on fast enough ACKs and retransmissions on fast enough paths. The draft also optionally proposes supporting path-aware networking, which would go beyond Quic multipath. Next slide, please. So these are the 3 core mechanisms that we propose. The first one is per chunk deadline tracking. We timestamp data when it's added to the stream queue, and the deadline for that chunk will be the enqueue time plus the relative deadline that we define for a stream. The second one is deadline-aware scheduling, where we map the deadline urgency to the stream priority. The third one is managing the stream lifecycle, where we track expired versus the delivered bytes. And if it crosses a configurable threshold, we reset the stream so as to not waste resources. The expiry condition can be the current deadline, current time is greater than the deadline of a chunk minus the one-way delay of the path we are sending it on. The one-way delay could be calculated from the half of the path RTT or using the receive timestamp extension for more precise RTTs. Next slide, please. So coming to Quic multipath, we have options to do better deadline compliance. by communicating with the receiver that we have deadline aware streams and the deadlines of those streams. So for that, we propose having a transfer parameter that negotiates support for deadline aware streams. And we do path selection based on the deadlines, and we strategically send acknowledgements and retransmission on the fastest path. The draft also talks about supporting forward error correction in multipath. This would be very useful for paths when we have a combination of paths where one path have random losses like Starlink, for example, and in combination with the cellular path, so that we could distribute the repair symbols on cellular path while using the Starlink for the main data transmission. Next slide, please. We can skip this. We have a prototype implementation based on Quic, and we evaluated doing deadline aware streams using Quic's simulation framework. On average, we found that we got 18% better deadline compliance than standard Quic multipath. And when we had asymmetric paths with high latency, high bandwidth path and a low latency, low bandwidth path, the deadline compliance was 88% greater than normal Quic multipath. Sorry, could you go back? So there was also a DMTP implementation based on Cyan, and we had field tested this by where we controlled an excavator remotely, and you can find the video where we compare it when using RTP over the internet. Next slide, please. We are seeking feedback on if there is interest in the Quic working group on exploring deadline aware streams. And after a brief discussion with the MOQ team, we think that their objects and tracks semantics fits well with the ideas of DMTP, where we could have per stack deadline aware tracks and per object deadlines. You can.
Cool. We are quite short on time, so I've locked the queue already. Thank you very much for your presentation. I really encourage people to reach out to Tony and have a chat. There is some discussion in the chat about where this was discussed in MOQ. I'm not an expert in this area, so I would encourage people to discuss some more and try and figure out if this is of interest or if there's alternatives, etc. Next up, we've got Louis to talk about interesting stuff. OAC. Yes. Thank you.
Hello, thank you. So we can move to the next slide, please. So this work was about the optimistic acknowledgement attack. Basically, the objective of the attack is for a malicious, for example, here, malicious client to send acknowledgements for packet not yet received. And the objective is to force its peer to increase its congestion window up to a point, for example, to generate congestion in the network or to congest the server. So it is example here, we acknowledge packets between 7 and 12, but they are lost in the network due to congestion. So it's basically an attack. Next slide, please. So it was described in RFC 9000, of course, and they say that an endpoint may decide to skip packet numbers to prevent from this attack. Next slide. So just to give an example, in the previous one, if we know we skip packet number 9 and directly go to packet number 10, when we receive the acknowledgements from the malicious client, we will see that the client is performing the attack because it acknowledges packet number 9 instead of packet number 10. Yes, so next slide, please. So that was theory. We wanted to know in practice how well this was implemented. So we took the 16 available server Quic implementations from the entrepreneur, and we noticed that 11 of them do not skip packet numbers, meaning that they are, at least theoretically, vulnerable to the attack. Next slide, please. So the work then was to try to attack these implementations. So we took a single testbed using the Docker images from the interrupt runner, and we limited the bandwidth toward the client to 5 Mbps. And basically, we designed a small predictor to generate optimistic acknowledgements to force the server into sending more data. So basically, what we could do was to increase the bandwidth sent by the server to more than 5 Mbps. Next slide. What is also interesting with Quic for this attack is that because Quic packets are end-to-end encrypted, nobody in the middle could see the content of the acknowledgement. So the only way to prevent the attack in the middle would be to see the traffic pattern of the client. And we measured that by sending such optimistic acknowledgements, the client do not increase the transmission bit rate. So the only person that can see the acknowledgement is the server, but it might be too late, and the client would perform the attack. Next slide, please. So at the end of this work, we discussed with the maintainers of the vulnerable implementations. Some of them already corrected their implementations. We had also interesting discussions. And for example, other maintainers decided not to do anything because they don't run server implementations and only clients. So that's true that it's a space of attack that is quite constrained. Next slide. Thank you. So that's what just about it. We have a paper describing much broader the attack and other measurements. For example, if we consider BBR instead of cubic as a congestion control algorithm, we presented 2 days ago at NRW. So if you are interested. And here I just mentioned the server to client flow, but of course this is independent of the direction and of the application protocol. Just a side note, I know that this attack exists in TCP since 1999, so that was just a measurement work. Thank you.
Thank you very much, Louis. Lars in the queue, do you want to make a quick point while we do a handover?
Sure, I'm here on the peanut gallery. Hi, so thank you.
Lights.
Just to clarify, right? You need to generate X for packets that the server has sent that have been lost. But if you generate X for packets that have not been sent, that'll cause an abort, right? So there is a window here. I wonder how tricky is it to generate those X and amplify this high?
So maybe I can show you later, but we had a small predictor. It was very simple. I can explain to you later, but of course you have to be careful and not generate too much acknowledgements, but it was not that difficult.
Right, thank you.
Thank you, folks. And finally, we have Jonas to close us out. Go ahead.
Okay, so sticking with the topic of acknowledgements in Quic, I would like to shed light on instant acknowledgements. Next slide. So what is an instant acknowledgement? Well, an instant acknowledgement is the acknowledgement of the client's connection request in Quic that the server sends as soon as possible. So without combining it together with the server hello, or like creating already the handshake packet. And that is also not like if you have a separate certificate store, then you also don't load the certificate separately. So what's the consequence of this behavior of sending the acknowledgement as soon as possible? Well, the client ends up with a shorter RTT estimate. And next slide. When is that relevant? Well, that is relevant in case of actual packet loss. So when the RTT estimate comes into play with the PTOs and when the anti-amplification limit is reached. Now let's look into 2 cases of packet loss in a controlled testbed, and we will try to assess Quic performance by looking at the time to first byte of those connections. Next slide. The first case is actually when the entire second client flight is lost, so it has to be resent. And next slide. And what you can see here on the x-axis is time to first byte, and you can see that orange instant ACK is always better than waiting for the certificate. The other case. Next slide. And that is simply because with instant ACK, you have a shorter RTT estimate, which makes you resend the second client flight earlier, which results in earlier time to first bytes. Next slide. The other case is actually when you lose everything after the first server packet. So that means in the case of wait for certificate, the client receives the acknowledgement and the server hello, and in the case of instant ACK, only the acknowledgement arrives. And what you can see already on the slide is that now instant ACK is significantly worse than wait for certificate. In our example, it's 180 milliseconds, but it actually depends on the default PTO of the server. And why is that? Well, because with instant ACK, the server never gets an RTT estimate of the connection, because the client cannot acknowledge an ACK eliciting packet from the server. You can mitigate this if you combine the instant ACK with a ping frame, for example, then both cases would look very similar. Next slide. And so what you have seen is that instant ACK can improve performance, but this is not always the case. So be a bit careful when you implement this. And as far as I know, this is actually the only solution to provide the client with a precise RTT estimate from the beginning of the first RTT. Okay.
Thank you so much for having me through those slides. Luckily, there is more time at MapRG tomorrow to go through these in detail. So if people want follow-up or questions, please go there.
Yes, and this is not just an academic problem. This is also deployed in the real world. You can see more tomorrow.
And on that note, I think Maria's emailed the list. There are other Quic-related talks at MapRG tomorrow for people. If you don't normally tend to go there, they look very interesting. I'm hoping to. Cool, thank you. We are over time for this session. Just to wrap things up, we have progress on issues, we have ideas, we will carry on the discussions, we will make sure that consensus is confirmed on the list for anything that might have been looking that way. We will look forward to the ballot on the rechartering and really want people to keep doing implementations and feeding us back. There will also be looking out for some working group last calls for some of those documents once the issues are resolved. Thank you so much. Enjoy the rest of your week.
Or unless you want to record it for posterity. I can't remember what you think. I don't know. You need 200. Well, if you want it to be a standard, if you want a browser to stick. Oh, sure. If you want to do it internally, knock yourself out.